Good morning. Our short presentation this morning introduces a project focusing on financial literacy that's presented us with some interesting challenges around pedagogy on digital platforms. And I wanted to introduce this as I think we feel ready to share an off-the-shelf solution. We've struggled to find use cases, and we're really interested in working with other people who might be thinking in a similar way. So we've been involved in learning platform and curriculum design work for a number of years now, and myself as if you like chief learning officer and also managing director of the company, I come from a background in specific maths learning difficulties, and so I've been always very interested in the interface between pedagogy and data and understanding the learner, data to inform and guide learning rather than evidence of learning. So we've recently been presented with a challenge that has given us an opportunity to think about many of the inefficiencies in traditional learning. And that's working with an NGO in Indonesia. Many people in rural areas are unbanked or partially banked and underinsured. There's relatively high smartphone usage. Rollout 4 and 5G is reasonably comprehensive. But the problem fundamentally was that how do we provide financial literacy education that leads to behaviour change that actually brings around really long-term positive differences in behaviour to a dispersed population. And so the challenges in terms of the learners that were presented to us were the challenges that we've all been dealing with, and indeed many of the presentations in this conference relate to these. Obviously, there's a wide variance in prerequisite knowledge, and this is really important when dealing with financial literacy. I think sometimes we make the assumption, a lot of financial literacy courses make the assumption that people will have the math skills that they need to engage with the course as soon as they arrive. In reality, that's far from the case. We know from the Skills for Life survey, for example, in the UK, that around about 25% of the population are functionally innumerate, and in fact, that 25% of the population sometimes fairly closely correlates with people that have insecure access to financial services. Particularly in Indonesia, although this is resolving itself, there's a fairly wide variance in access to formal learning opportunities. Different people have different endpoints depending on where they need to go. If we're looking at seaweed farmers who want to improve their supply chain, then not only do they need the financial literacy, but they need to then start developing a level of digital literacy as well. So like many people, our solution has always been adaptive initial assessment and an adaptive curriculum. In addition, we offer a super curriculum we believe is really important, that we take people back to the prerequisite contextualized maths knowledge that they would need in business or in financial literacy. So we take them back to the mathematics, to core digital literacy. And then we take them forward as well into business literacy. And we very much see the connection between areas of knowledge as being really important. Again, that's something I think as maths educators, we've traditionally recognised the connectivity of mathematics. Technical challenges were slightly different because of the nature of the population we were working with. We had to make our mobile first. Most people use smartphones in Indonesia. There's not certainly away from Jakarta, there's not much use of any other device than smartphones. most people have access to 3 and 4G. 4G is being rolled out fairly quickly. So we need something to be data light. We need to balance high latency and poor bandwidth. But obviously we needed to offer a compelling user experience as well. We need, behavior change to happen. We want people to get a return on their investment for the learning that they did. So confronted with this, we started to think about ways that we can deal with this. And the first thing is that we thought very much about off-the-shelf solutions, both in terms of CMS and in terms of database, rather than building from the ground up. A lot of adaptive learning platforms have been, you require data scientists, computer scientists, mathematicians to be involved in sort of getting your algorithms right. Now we've established that, what we had seen was resources turned towards university students because there was more income, more return on the investment there. We're starting to see now that we understand how we can use machine learning techniques to move and refine the journey through things. So off-the-shelf solutions where they were available, and learning is fundamentally fuzzy, so we needed something that would deal with the fuzziness of that learning, and the result was our decision to use graph databases. So within a graph database, every learning touch point is seen as a node, and the relationships between nodes for learners are managed by weighted edges. So the adaptive part of the learning process becomes basically a graph traversal problem, which makes it very easy to conceptualize and visualize how you're actually moving people through initial assessments, how you need to refine the initial assessment so it's effective and efficient, and how you can then move people through the curriculum. You look at a graph, you look at graph theory, and you can relate that very definitely to a curriculum. So we chose Orango as our graph database largely because the nodes and edges are managed as JSON documents. This makes life a bit easier for developers, and therefore it makes life a bit cheaper. The dialogue with the CMS is relatively straightforward. And in the case of the initial assessment, we've managed it fairly straightforwardly as a Markov chain Monte Carlo. I say straightforwardly, it did require quite a lot of thinking to get us to a point at which it's working. So the advantage of a graph database, it's quick and economical to run up. There's a very straightforward link between the front end, the database, and then the ML tools. Orango and TensorFlow talk very well together. The nature of an off-the-shelf graph database means that it's fairly straightforward for a global rollout. And for curriculum designers and computer scientists, playing with fuzzy logic, Bayes and graph theory is actually really interesting. It's presented us with a really interesting challenge. Downsides is that we're finding it really difficult to find other use cases relating to graph databases. So it feels a bit lonely, and we would love to talk to you if you're thinking of similar things. And the other thing is that, because we're dealing with off-the-shelf services, sometimes we've had to spend considerable time refocusing from the traditional use case to what we've done. So it's felt very much like, we're working with this on our own. Anyway, I just wanted to introduce the idea of graph databases to you. I hope that you found it interesting, and if you would like to talk more, we'll stay around for questions, or do drop us an email. So thank you very much.